All right, so we are solving a question on logarithms and exponents, and it's a question that confuses students a lot. When they see some of these things scattered around like this, they get a little bit worried. But the first thing is that in logarithms and indices, we are so much concerned about the base. So when you see numbers, for example, the number with an exponent here is 5, 5, 5, 5. So it means that it's a guy that you are going to manipulate to arrive at your answer. So let's go into the details and see how we can solve this question simply. Now, I'll rearrange this thing so that the base become very prominent. So 49, I would want this to also look like this. So I can write it as 5x all squared. This is using the power rule. So this side, I'm going to employ the product rule, which says that when you are multiplying numbers of the same base, you add exponents. So it simply means that when I see two exponents adding, I can also reverse them to be a multiplication. Yeah. So this is 8, 5, 2x times 5 squared plus 5, 3x plus 3. And this also, I can do the same thing for it. That would be 5 3x times 5 to the power 3. And coming back to this side, I'll have 2 5 to the power x minus 49 5 to the power x all squared equals 8. This can also be rearranged to be 5x squared times 5 squared plus 5x cubed times 5 cubed. So I want to get to this setup. I can now have this to be, can now say, okay, let's 5 to the power x be equal to y. 5 to the power x be equal to y. And I'm going to have 2y minus 49y squared equal to 8y squared times 25 plus y cubed times 5. 5 cubed is 125. So I'm going to have something like this. 2y minus 49y squared is equal to 8 times 25 is 200y squared plus 125y cubed. I can rearrange this to be a quadratic equation. Oh, first of all, it will look like a cubic equation first. That will be 125y cubed minus 200, sorry, plus, still at this side, 200y squared plus 49y squared minus 2y equals 0. So just when I get here, I can decide to divide through by y. Just simplify my work into a quadratic instead of a cubic. So this will now be divided by y. If I divide this by y, I'm going to get 125y squared. I divide this by y. This is 249. Adding this to becomes 249y. Then this is minus 2 equals 0. Divide this one also equals 0. Now I can solve this as a quadratic. So I ask myself, what two numbers will I multiply to get 125 times minus 2, which is to get 250 minus 250 exactly. And what two numbers am I going to add to get 249? These are going to be the factors that I will use. Okay, so what two numbers are those? It's 250 and then minus 1. So those are numbers that will fit in here. 250 and minus 1, 250 and then minus 1. So I can now say that this thing will become 125y squared plus 125y squared plus 250y minus y minus 2 equals 0. 125y squared plus 250y minus 2 equals 0. So if I have this, I'm going to have 125 house 125y here, and then y plus 2, then here minus 1 into bracket y plus 2 equals 0. So if I'm at this point, I can now say 125y minus 1, and then y plus 2, all of this equals 0. Y plus 2 equals 0. So we would have something like this. Y is equal to 1 over 125, or y is equal to minus 2. But then 1 over 125 is the same as 5 to the power minus 3. Still on indices, 5 to the power minus 3. Or y is equal to minus 2. However, the question didn't ask us to look to find y. The question asked us to find 5 to the power x. So it means that 5 to the power x is equal to 5 to the power minus 3. Or 5 to the power x is equal to minus 2. Now, if this is the case, then you can just simply say then x is equal to minus 3. Or at this side, since I can't easily express minus 2 to be an exponent of 5, I would have to fall on my logarithms. So that would be log to the base 5 of minus 2 is equal to x. It implies that x is equal to a certain value, but we know that we can't find logarithms of negative numbers. So this is going to be undefined, but this is going to be minus 3. So our final answer is going to be x is equal to minus 3. And this is the answer to this whole question. We'll solve other questions in the next video to see how the other variations of this same question. All right.